Hello everybody, welcome back to another video with Mr. Coder, and in this one I'm going to show you how to solve substring and subsequence. Question B from Educational Codeforces Round 167, rated for Division 2. So you're given two strings A and B, and they're both consisting of lowercase letters, and a subsequence of a string is a string which can be obtained by removing several, possibly 0 characters from the original string. And a substring of a string is a continuous subsequence of that string. For example, consider the string ABAC. And then for subsequences, since you can delete any of them, so for example, you can have ABC, AB, AA, and you might be wondering like AA, AC, like that, those won't work because in substrings because they're not continuous. But that will work for subsequences because you delete the B, or for AC, you delete the BA. So those are the difference between subsequences and substrings. And your task is to calculate the minimum possible length of the string that contains A as a substring and B as a subsequence. So if we take a look at this first one, so ABACB. Well, first I'll talk about the input constraints. So A and B are less than or equal to 100 of length, and there's a maximum of 1,000 test cases. So for the first one, ABA and CB, you can do CABA because then ABA is a continuous substring of the new one, and CB can be obtained by deleting this A down here. And for this ERCF, there's no common thing, so you'll have to include both as a whole. You can do CFER, ERCF, or CERF, or whatever, and those will all work. But you just need to print out the length, the minimum length, so you won't even need to find it. And then, for example, for this one, contest and test. Contest is a substring of contest, and test is a subsequence of contest. It's also a substring, but you're looking for a subsequence. Well, it's also a subsequence, but it's not a substring. Well, it's also a substring, so it's both. So that's why it works. And if we notice any patterns, we notice that each one is always at least the length of, it's always going to be at least the length of A, because you need to include the whole A as a substring. And then noticing these constraints, you can notice that this will work. And my approach was, so first I had the minimum length so far will be the size of A, and I have the minimum for the next part. And then I loop through all possible substrings of B that can possibly be inside of A. I'll go through all possible substrings. So I just like loop through because I don't need to worry about deleting, because because the thing about this is if you have any of the things in B in A, it has to be a continuous amount, because the only place you can actually insert stuff is at the beginning of the A and the end of A, which means that it has to be continuous. And you can do this in the length of B squared time by going through and then having a current string that you keep on pushing back. And then you see if it works. If you see if it's an A. So in other words, like for this works function, you just see if this I ends up being equal to N. If it does, then it works, and then you get the minimum of the current minimum and the B dot size minus the current size of your current substring. So then if the minimum is long max, which means that for example, this ERCF, it'll have long max, and then you just print out the combined two sizes. Otherwise, you print out the A dot size and then this minimum. And that will get you accepted for substring and subsequence. Question B from Codeforces Round, the Educational Codeforces Round 166, rated for Division 2. So yeah, thank you for watching this video. If you like this one, please like and subscribe, and I'll see you in the next one. Bye.